Okay, now we're going to deal with tangent. Tangent is a little bit different than sine and cosine because both sine and cosine have r in their x, y, r definitions. Since we're working with the unit circle, r is equal to 1, and so they simplify. But tangent, we know that's y over x, doesn't involve r, so it doesn't matter that we're on the unit circle here. The, 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 the fraction doesn't simplify because r is equal to 1, so tangent has a little bit different spin to it. It's not really difficult, they're just a different way to look at the problem. So I have tangent of these three basic angles here, using, everything's in quadrant 1 for now. But notice, tangent of pi over 6, this is still the same as before, the pi over 6 reference angle family. It still corresponds to this triangle 1/1/2 square root of 3 over 2. This is pi over 6. Now we know tangent is y over r. That's opposite over adjacent. That's going to be, in this scenario, that would be 1/2 over the square root of 3 over 2. Now, I'm going to write over here in red something that you don't need to write every time, but I want you to see what's happening. We would think tangent is y over r. That's the vertical divided by the horizontal. So in this case, that would be 1/2 divided by the square root of 3 over 2. But of course now this is a complex fraction and we do need to simplify that, but that is the same thing as 1/2 multiplied by the reciprocal, and something happens every time. This becomes 2 over the square root of 3, and the 2's cancel. We're left with 1 divided by the square root of 3. And so when you're thinking of tangent, what you can think of is opposite over adjacent, and you may ignore these denominators because the denominators are going to cancel anyway. Tangent is vertical divided by horizontal, in this case 1/2 divided by radical 3 over 2, but you may ignore the denominators. We know the denominators are going to cancel when we form the complex fraction. So the short version is this: tangent is the vertical divided by the horizontal, but all you need are the numerators. Do you understand that? Do you see that? All you need are the numerators because we know denominators are going to cancel. So tangent for pi over 6, again, we have this triangle in our mind's eye. You can draw it out if you need to, but it's the vertical divided by the horizontal, y over x. So that becomes this numerator divided by this numerator. It's 1 over the square root of 3. All you need are the numerators. All right, tangent pi over 3. It's the same triangle, but remember, for pi over 3, we're going to upend the triangle and write it this way. This is now pi over 3. This is now the square root of 3 over 2. This is now the 1/2. And so tangent is vertical divided by horizontal. The vertical is now the square root of 3 over 2. The horizontal is now the 1/2. But just like before, do we see it? I'll do this one more time. In this scenario, vertical, square root 3 over 2 divided by horizontal 1/2. But once again, the denominators cancel. And this becomes the square root of 3 over 1, or simply the square root of 3. And so, when we're forming tangent, you may ignore the denominators. So tangent of pi over 3 is radical 3 over 1, or simply radical 3. Do you see that happening? You may ignore the denominators. Tangent for pi over 6 is vertical divided by horizontal. That's 1 over radical 3 because we ignore denominators. Tangent is radical 3 over 1 because we ignore denominators. And then tangent of pi over 4, the same kind of thing happens. Except now this is the triangle. Remember, this is our modified triangle. This is 1 over radical 2, this is 1 over radical 2, but the same thing occurs. We may ignore the denominators. It is the vertical distance 1 divided by the horizontal distance, also 1. Tangent of pi over 4 is 1. Strictly speaking, it's 1 over 1, but we can simplify that on the fly. We may ignore the denominators, it's 1 over 1. We may ignore denominators, it's radical 3 over 1. We may ignore denominators, it's 1 over radical 3. So sine is the y coordinate, it's the vertical value. Cosine is the x coordinate, it's the horizontal value. Tangent is y divided by x, that's the vertical divided by the horizontal, but you may ignore denominators. Once you get used to this, you'll do it almost automatically. Remember, what matters is not so much speed, but accuracy. Yes, you want to be able to do them relatively quickly, but it's not speed that's the important piece, it's the accuracy that matters. You don't want to have to sit down, and certainly don't want to have to go to a calculator to do this. You don't want to have to sit down and work this out in a slow pitch, but better to work it slowly and get it correctly than to try to work it too quickly and foul things up. So again, tangent is the vertical value divided by the horizontal value. This then works the same way as cosine and sine in terms of the other quadrants and the reference angle families. So the next video I'm going to work with is having to do with what if we have tangent of these same reference angles but in the other quadrants.